Ever wondered how natural gas gets from the well to your home? There's a lot that happens between the time a well is drilled and the time gas heats your home or cooks your food. The journey is just beginning when the gas surfaces. The next stops for gas: pipeline, processing, and compression. Most of us don't realize gas straight from the well is very often unusable for commercial purposes. It's mixed with oil and water, which need to be removed through several processes. And gas needs to be brought to the proper pressure for transport. Compression and processing equipment are easy to spot, but the pipeline bringing gas to compressors and processors and eventually to your home is almost always underground, invisible except for markers showing where the pipe is buried. If you're wondering how all this equipment works in concert to make gas a usable and efficient source of clean-burning energy, well, I'm glad you're curious, because we've assembled a team of industry experts today to give you an inside look at all the machinery and parts in the field that bring natural gas to a transportable state. We'll see the pipe that carries the gas throughout the route from the wellhead to where it's sold. Now, this is called the gathering phase of the journey. We'll see how gas is processed or separated from oil and water so it's usable, and we'll visit many kinds of compressors giving gas the boost it needs to travel through the pipeline system safely and efficiently. Straight from the wellhead, gas sometimes can flow directly to a main transmission line, which then takes it to a sales meter where utilities purchase it. But gas often needs processing and additional pressure at the wellhead. In fact, there can be so much water mixed with the gas that water actually prevents gas from flowing. It literally weighs it down. Now that's when you call in a gas lift.
This is how a gas lift works on this location. Compressed gas is diverted back to the well through this valve right here. From here, the gas is pumped down the casing, forcing the fluid, which is weighing down the gas, up the tubing. This allows the gas to flow more freely.
The water ends up in deposit tanks, like these, and the gas flows into the pipeline. Gas travels in an above-ground steel flow line from the wellhead to what's called a production pack or production unit, also at the wellhead location. This unit separates out a good bit of the oil and water present in all raw natural gas. It's usually used in high-pressure flowing wells. The production pack helps control the flow of gas coming from the wellhead.
After the fluid leaves the production pack, it can be sent to a heater treater like this one. At that time, the heater treater uses heat to further separate the oil and the water and send it to the appropriate tanks.
Excess natural gas that powers the heater treater and pushes fluids through the system is recovered and sent to a small compressor called a flash gas compressor. Gas compressed by this unit typically travels a sales pipeline directly to the utility sales meter. For still more processing, you'll sometimes see separators at the wellhead site too. Low-pressure compressors often are used as a final step at the wellhead to bring gas to the proper pressure for the next part of its journey, the pipeline. Before the gas enters the line, a sales meter records how much the well is producing. The pipeline brings gas to a location where it'll be processed and compressed again, depending on its condition and what the utilities buying the gas require. Pipelines from the well to the next processing facility can cross miles and miles of land that's treated with the highest respect for its existing condition. Once the pipe is safely installed underground, the area will be restored to its former state. When the pipeline's path is cleared, miles of steel pipe are positioned. We call this stringing the pipe. Different pipe is used in different situations during this gathering stage of transport, when natural gas is transported from the well to a central processing or delivery facility. This 16-inch diameter steel pipe is often used in pipelines. The green color is actually protective coating. Around here, pipeline can be as narrow as 4 inches in diameter all the way up to 48 inches, depending on volume and pressure. The higher the pressure, the more gas you can move through a smaller diameter pipe. You can also find polypipe throughout the gathering system, used in lower pressure applications. The strung pipe is resting on skids, wooden platforms which protect and stabilize it until it's placed in a trench.
Part of it could be soil conditions. as far as what we want it, but 48 inches is basically a standard. Landowner could want it at 50, 60 inches deep cover, and in urban areas it's going to have to be deeper because of existing pipelines or telephone lines, anything like that that's underground is going to have to be deeper.
Before the pipe is buried, it's leveled with precision accuracy and fused with 3 super strong welds at each joint.
They're lining the pipe up right now. Then they'll be using a inside line-up device, which is like a balloon. It will compress and go out against the outside of the pipe. It'll keep it in alignment. And then they'll run 3 passes with the welder on it. And that's what the guys are doing. It's coming back behind. They'll run their 3 passes and continue down the line.
X-rays, taken on site with a special mobile unit, determine if there's even the slightest flaw in the welded joint that could lead to weakness.
First off, we cone off the area for our 2MR boundary to keep people out of the area that we're testing in. And then we strap the pipe, the welds, with cassettes, and we take 3 views. We use Iridium 192 for its radiation to take a picture of the weld, then we process it, and then we view the film for any defects.
Any potential problem areas are revealed, removed, re-welded, and re-X-rayed. The joints are determined sound, and the pipe is wrapped with pipe joint coating to protect the joint underground. Soil conditions might require a rock crusher to pulverize larger rocks in the trench before backfilling, so there's less risk of damage to the pipe's coating over time. A rock shield can be wrapped around pipes to further protect them if necessary. Safety is key when installing a pipeline. When a trench is ready, the pipe goes in.
After it's welded and they've got the trench, they'll bring 3 side booms in and use a process called cribbing, and they'll lay the pipe into the trench. The pipe will have enough flex that it will not allow any damage to the welds or to the structure of the pipe.
There's one more important safety test before gas flows through the line. The underground pipe is filled with water that reaches a pressure 1.5 times greater than the highest pressure pipe gas will ever reach. Any possible leaks will be detected during this hydrostatic testing and then repaired. In some cases, the pipeline needs to travel around or under an obstacle that can't be disturbed, like a stream, a rock formation, a road, even landscaping. So pipe can navigate these areas a couple of ways. Now, one way is through a process called directional boring, which brings the pipe under the area.
We dig the hole on one side or the other, put the boring machine down in the hole, and we will drill a 2-inch hole under the road, and it will be attached to a cable on the other side with a boring tool that will bore the hole out 4 inches bigger than the pipe diameter we are using. And then that allows your pipe to be positioned wherever you want it under the road.
This kind of engineered directional drilling is actually a lot like the technique used in horizontal exploration for gas. Another way to get pipe flexibility is by bending it. Now, this procedure is overseen by skilled engineers who can create an actual bend in the pipe without stressing the pipe or its joints.
Bending is necessary to go around obstacles, or to come in straight across the road, or to come in to a certain point in a location to where they want to hook up the well or meter run, to go around land in particular, or a barn or whatever he may have, just to reach a point A to point B.